In this series of videos, we are exploring the world of AI by using PowerBASIC to connect to the Ollama Windows server and run queries against the Open AI GPT OSS 120 billion parameter large language model. We achieved this in the last video. So in today's video, we're going to be doing some amendments to our PowerBASIC application to make it more user-friendly and robust. Here you can see the Windows client that we have constructed. There is a place for the prompt, a drop-down list to select the model, and the option of providing a text file for input to the model. And finally, an HTML control to display the output. The first change we're going to make is to add an icon for the application. But rather than build the icon ourselves, we're going to try to get the large language model to generate one for us. So how can we achieve this? We've had some success in outputting files in HTML format. So we're going to try that for our icon. So first we need to enter a prompt. We want to create a 32 by 32 icon. And the rest of the text is to say displaying a sun flare. As the application is set up to output automatically to HTML, we should get our output in the HTML control. So let's run the query and see what comes out. Now we can see that all our CPUs are fully loaded and the amount of memory being used is increasing rapidly. So we know the Ollama server is functional and running our query. So we'll just fast forward through this to get the result. And there our application appears to have completed. Well, let's have a look at the actual output file itself. There's our output file, so let's open that in Notepad just to see what we get. Well, it has generated this in SVG. So we may be able to, now here we have the source. How can we actually get this into something we can use? Well, let's grab that and we'll try and create an HTML page to put this in. Well, it has given us a very basic one. Not quite what it was after, but it has actually created something we can use. And we want to paste this into an icon editor. And we'll go from 32 to 32. And we'll paste this in. And there is our image. And there we have an AI client with our new icon. It's not perfect, but it'll do for the moment. Let's come out of our application and we'll attempt to put our icon in place. And we can add that into the application by using the resource icon command. We've given it a name and we've specified the name of the file. So if we go where the dialog is specified, we can add this in before we show the dialog to the user. So if we try running it now, we should see our icon at the top. It's not particularly obvious, but it is an icon. So one of the other changes I want to make is to make the text in the prompt box larger. So we need to increase the size of our font. So let's go into the form designer. We can do this quite easily. Double click and select the font button. At the moment we're on 8 point. Let's take it up to 14 and apply that. And we'll then save that back to the code. And what should have been added in is there's a font new command been put in automatically for you for 14 point for our selected typeface. And it's setting the control font on that object. So if we run the application now and we type in here, we now have a bigger font quite happily. So the next thing I want to do, I want to add in a button here beside the input file to allow the user to be able to browse to the file going to be input rather than having to type it. So let's go back to the code. So first of all, we'll need another icon. This time I'm going to use an icon we've used previously, This is an image of a floppy disk with an up arrow, and the icon's called load.ico, so we take exactly the same approach to get this in. We need another resource command. And there it is, we're calling this one image browse. So we need to add a new image button to our dialog. So we can pick an image button, and we can place this on the screen, and we'll make it suitably small to allow the user, so get this out of the way, make this suitably small to allow the user to be able to use it quite easily. And there is our icon. And we'll move it slightly to the right, and we'll call this one image browse. And once we've okayed that, we will save that back to the code. And if we have a look in the function that creates it, see at the bottom, there is our image browse button. Now we have to set that image control to contain our new icon. We can do that again in code before we show this to the user. Using the control set image button. Takes 3 parameters, the handle of the dialog, the handle of the button itself, and the resource we're going to be loading. If we run this now, we'll now see there's an icon showing here quite happily. Could do with being slightly larger to accommodate that. So let's increase its size. It's 15 by 15. Let's go for 18 by 18. That's slightly better. Right, now we also want that invisible until the input file is actually ticked. So we'll need to add a little to the logic in the callback function, the event handler. So let's nip into the event handler and put some more code in. Now further down here, we initially hide the input file. So we're going to hide the input file and the browse button. We can do this quite easily. We'll use a prefix command because both of these lines of code are going to have this control hide command. And we can enlist any of the controls we wish to hide. So once the user has actually selected the tick box, we'll want to make both of these controls visible. So if we go further down the code, we'll find that particular event. So there we are. This is where the input file checkbox has been ticked or unticked. So we'll make the same change there. And we also need to put it in for being normalized to make it visible to the user. There we go. So if we run that code now, it should be initially invisible. And when we tick the box, it will be visible to the user. There is, of course, no code underneath it to do anything. So we'll need to put some code when the user clicks on that button. So once more, back to the code. So we'll want an event to handle clicking on the browse button. And we're going to need a couple of variables here to handle this neatly. We want the user to see a display open file dialog when they click on that button. So first of all, we'll set some flags. We want the file to exist and the path to exist. We don't want the user picking a file that does not exist on the hard disk. Next, we want to filter it so it's only text files the user can select. So we will next set a filter. That filter will display text and only display that which has a text extension. And next, we're going to use the display open file command to allow the user to select a file. This is an inbuilt command to PowerBASIC, which triggers the standard Windows dialog for the user to select a file. It takes a number of parameters. We're first of all giving it the handle of the dialog. We could specify the X and Y coordinates at which this dialog will appear, but if we leave them blank, Windows can actually sort that out for you. Next, we're placing a piece of text the user can see. Please select a text file for input. We're then giving it the initial starting path, in this case the path of the executable, the filter we have specified above, text files only, the extension which the system will take, and the flags, and anything the user picks goes to this new variable str file. If this file is anything other than an empty line string, then we have selected a file. So we can test for that and populate the text input box. Before we attempt to run this code, we need to actually specify these variables. So at the top of this function, we shall put in our declarations. One for the flags, one for the filter, and one for the file. If we run the application now, tick the tick box, click the button, we now get a dialog. So from here, we can actually specify the file we wish to add. And there it is on the list. You can, of course, browse to other files or folders on your computer. And if you pick no file at all, it leaves this as it was before. So the other thing we noticed when running the application was once the application is actually committed and waiting for Ollama to return a value, this dialog becomes unresponsive. This is because it's waiting entirely on the result coming back from Ollama. In order to make the dialog responsive, we'll need to use threading. So back to the code and we will create a thread. To make this a little bit easier for us, I'm going to create a user-defined type for all the data we're going to pass to Ollama. So everything the user either inputs or selects from the main dialog will be populated into this user-defined type. And I'm going to create two global variables, one as a user-defined type and one for our thread handle. So if we go back to the event handler, this is where we're actually calling Ollama. If we look further down inside this event handler, we can see the Run Query button. This is the code that is executed when the user clicks on the button. First thing we want to do is disable the button to prevent the user clicking on it multiple times. That can be done easily using Control Disable, then specifying the handle of the dialog and the handle of the control. I'm using CTL to specify that whatever control we happen to be inside, this is the one I want to disable. Next, it would also be useful to overwrite the HTML control to make sure that there's nothing in it. We can do this quite easily using code we've already used to put a blank output into that control. This will save having a previous output sitting on screen while the main query runs. Now we have to pick up the inputs. And what we're going to do here is, rather than go to these local variables, we're going to go to our user-defined type. I'm going to be making a change to the dialog again. I want a checkbox for HTML format, so that way we get to pick whether we want HTML format or not. Next, we're picking the model. Next, we want to work out is there or is there not an output file. No change to the logic here, just to the variable we're actually using. Next, we're going to pick up the prompt. Because there's always a possibility the user may key in a multi-line prompt, we'll want to remove any control line feeds and replace them with a space character. We can do that quite easily by using the replace command. And we're still going to be using the same output file. And we'll still want to update the word processing on the status bar. And the next part is where we're going to be making some changes. First of all, we will populate our user-defined type. This is quite straightforward. We're just populating each of the elements within the user-defined type with the value we've picked up from the screen. And we're also populating the handle of the dialog. Next, we're going to replace all of this section of code here with a call to a new function which will be our threaded function. So we will take out this section of the code. And we will replace it with one line of code which creates our threaded function. And there it is. Because this is a threaded function, we need to pass it at least one value. And the output from this command is the handle of the thread. This thread will then run away in the background, and this program that we see in front of us will continue quite normally. My intention is for the thread to post a custom message back to this event handler to let it know that it's actually finished processing. So we'll need to create a constant to handle this custom message. So let's go back to the beginning of this function first of all, and we will create that status variable. Now back to the beginning of the code. Down here, where we'd specified the handle of the HTML control itself, I'm going to set up two new constants. One to handle our progress complete message, and one as a timer. We'll come back to the timer in a moment, but let's complete the work on our thread handling. So we go back to the event handler. We need to put an event in to handle this progress complete. So before our WM command, we're going to create a new event for progress complete. And there it is. So our first task is to close the thread down and free up any memory it was using. And we can do that by using the thread close command. Next, we want to populate the HTML control with the value of the output. So first, we'll test to see if we have actually got an output file. If we have an output file, we can use it. If we haven't, we'll want to create a new templated file called nofile.html. This will display a no file message on the HTML control so the user can see that nothing was generated. We'll create that file in a moment. And as we did before, we'll reuse the populate HTML function to populate the control. And we can tell the user on the status bar processing is now completed, and we can re-enable the button we disabled when we started running the query. So that completes the handling of the beginning and the end of the thread. We now have to create the function which is the thread. When creating a threaded function, it must always begin with thread function to specify to PowerBASIC that we are indeed creating a threaded function. And any value we pass it must be passed by value. So what we're going to do inside this threaded function is much the same as we did in the one before. For handling the processing, we need to call Ollama on the command line and give it an input. In this case, all the values are going to be coming from our user-defined type. So these are our local variables. One for the command string, one for the batch file to run, one for the input string, and one for the prompt. If there is no input string, then we don't have to actually specify that to the batch file. If one has been provided, we can specify that in the input string and it will appear in the batch file that Ollama will take to run the command. We can then set the prompt as being the trimming of the value in the user-defined type. We can test for HTML format and make it provide output in HTML format if that has a value of 1. And the rest of the code will look remarkably similar. We're again using Ollama run, and then followed by the model, the prompt, the input string if it exists, and the output file. In the previous code, we used a try-catch block to wipe any existing batch file and output file. This involves writing several lines of code every time we want to do this. As this is a fairly common thing, I'm going to create a macro to save us a little bit of typing. And I'm going to place that macro within our file handling routines library. So we will add that as a new library at the beginning of the application. If we have a look at that file, this is the new macro we intend to use. Anytime we put in mwipe_file followed by the file name, it will put these lines of code in at compile time. In this particular macro, we don't really care whether the file exists or not, but if it does exist, we want to erase it using the kill command. So it means the command to actually wipe a file is much cleaner. It's a single line of code, wipe a file followed by the variable holding the file to be wiped. Rather than the variable name, you could hard-code it and put in the name of the file to wipe. So now that we've handled the wiping of any existing files, we can now save the batch file and attempt to execute it. This is all remarkably similar to the function in the last video. The last stage of this threaded function is to post a completed message to the dialog. We can do that quite easily using the dialog post command. This will send a message back to our dialog using the handle we've stored in the user-defined type, passing it the value progress completed. So before we do a compile, I'll need to remove this append to file function because it already exists in our file handling library. So if we try a compile now to make sure we've got everything. Oh no, we haven't done the checkbox on the dialog yet. And there is the code in to handle our checkbox for HTML format. I'll just update our constants at the beginning of the application. Right, our application compiles quite happily now. So if we run our application, and we'll want to run a quick query to make sure that our threading is working correctly. Let's try a quick query. How many countries are in the EU? And we'll want that to default HTML format, so we'll change that. That's one change we'll have to make. We run our query now, which is running quite happily. And if we click on the dialog, we should be able to move the dialog around the screen without any no response messages coming up. It's responding quite happily, and the background task is running as a thread. So we have cured the problem of our dialog being unresponsive. So we'll just do a quick fast forward through to the end of this to make sure we get an output. And there is our output, and we don't seem to have an output page. So we've obviously made some error in our code. So let's go back to the code and see what we've missed. Well, we do have an output file, which does give us the output. So why was it not displaying on our control? Perhaps we missed something in the population of the user-defined type. So let's have a look at that first. This is one of the advantages of actually having a batch file. We can see what we passed. Well, we did pass the right path to the output file. So let's have a look at the code where we handle the post-processing. Right, that should fix our problem. And the other thing we wanted to change was to pre-select the HTML output as ticked. So we will put a line of code in here to do that. Right, so if we run the application now, it should be pre-ticked, which it is. Now, the other thing I wanted to do before we finish up is to check to see that the Ollama server is actually running before we run our query. Now, we can see from the system tree down here that the Ollama server is indeed running. However, there's a possibility it may not always be so. So we want to check that. So I'm going to create a separate dialog which will launch before this dialog, whose job it will be to actually check to see the server's running. So let's go and create this new dialog. And we want this to be a startup dialog. So to save a little time, I'm just going to paste this one in. And it's going to give a title of checking Ollama server. It's going to have the same icon on it, and it will say waiting. And we will have a timer and an event inside the callback function. So here is our callback function. We will set a timer of 1 second, and then 1 second later, after we've displayed the dialog to the user, we will kill off the timer, and we will run a new function called check Ollama server. If that returns true, then we will say the dialog can end, and we can then go on to the next dialog. Otherwise, we will abort our dialog. So we will need to change our PB main function, so it calls this new dialog first. And here is our changed PB main function. We have a local variable called result at the top. We call the new dialog first a startup dialog. It will return a value. If that value is ID OK, then we can go ahead and start the main dialog. Otherwise, we will display a simple message box to the user to say that the Ollama server is not running. So now we need to create the function which tests to see whether Ollama is up or not. We're taking a single parameter in, which is the handle of the main dialog. We will create some local variables. Again, we'll take the same approach. We'll have a command variable holding the command string, a batch variable containing the name and path to the batch file, and an output file. and we will use a very simple curl command to check the version of Ollama. If this returns a value, then we know it's running. If it does not, then we'll know Ollama is not running. So we will set the name of the batch file, we will wipe any existing batch file and output file. And we will save our value to the batch file, as we have done several times before, and we will attempt to execute it. And once executed, we now want to pull in the file Ollama server.txt. If that has the content of the word version, then we know the server is up and running because it has responded to us. If it returns anything else, then the server has not started for some reason. And we'll give a message to the user to say, please start the server. Right, if we try running that now with the server up and running, it works fine. The first dialog comes up, it talks to the server, it gets a response, and our main dialog appears. So if we deliberately stop the server running, quit out of that, then run the application, we'll get the first dialog up, and we should get the message box to say the Ollama server is not running, please start the server. So we're given two message boxes to the user to indicate that the server needs to be started. Once the user starts the server, either by launching the main dialog and then quitting, we'll see in the system tray the server is still there. If we run the application once more, it will run quite happily and then go to the main dialog. So there's one last change I want to make. I'm not totally happy with the icon, so I'm going to run in the background the query once more to get Ollama to generate another icon. And there is our new icon, which looks a lot better. Ollama's second attempt at generating an SVG file is much more useful. So let's try running the application once more. And there is our new icon, showing quite happily at the top of the screen. And we can see on our taskbar, there is an icon that stands out a little more than the last one. So in summary, what we've achieved today is we now have a threaded application, which allows the main dialog to remain on screen and be responsive while the query is running in the background. We have given the user a tick box on screen to allow them to untick when they don't want HTML output. We've also tidied up some of the code to make it a little more easier to use and more robust from the user's point of view. Hopefully you'll find these changes useful in your own applications, but that's it for today. Thank you for watching.
Thank you for watching today's video. Please feel free to click on the link in the description below to discover more videos.